The advantage to a person being x-rayed with the Explorer is they're going to get a better x-ray. In a nutshell, that's it. And the doctor's going to give you a more accurate diagnosis, and that's what this is all about.
The taking of x-rays has entered the digital age. Just as small digital cameras have replaced film cameras, the digital x-ray is destined to replace the film x-ray. Taking x-rays is becoming faster, more detailed, more available, safer, and less expensive than ever before, thanks to the persistence and vision of Robin Winsor, recipient of the $10,000 Manning Innovation Award.
We've had x-rays for more than 100 years. In November of 1895, Röntgen discovers, quite by accident, the x-ray. That's why they're called x-rays, because he didn't know what to call them, so they're x-rays, unknown. Well, an x-ray hasn't changed much in all that time. We still have to process it with chemicals, which has an environmental impact. It takes some time to get it through from the processor so you can see your results. And it's not as precise as a digital image. It doesn't carry as much information. A digital x-ray gives tremendous benefits to the patient in that we can see far more information, 16,000 shades of grey as opposed to only about 100 or so on film. For the hospital, it's much faster, so we can move many more patients through. And of course, it's much cheaper because we're not spending money on film and chemicals with every shot. So faster and better seemed well worth doing, and that's where the project started. Well, the best way to understand that technology is to go and have a look. So we should go do that. Well, as with any X-ray system, we need an X-ray source. So here we have the X-ray source. But where it starts to get special is here once we get into the detector head of the Explorer. The X-rays come through the patient's body, strike the front surface, and just inside there's a scintillator. What's a scintillator? That's the layer that takes the X-rays, intercepts them, and turns them into visible light. That light then comes back here and bounces off a mirror at 45 degrees, sending the light off down there. The X-rays continue, ignoring the mirror and just going right through it, and they're absorbed at the back of the system. So now we've separated the two. Through a very special lens that's made for us in Midland, Ontario, and then into the CCD camera. What does the CCD camera look like? Well, if you look at the CCD in your own home camera, it might be about this size. Quite small. And if you look at ours, well, it's actually quite a bit bigger. There's a very, very large sensor here, 16 million pixels, sealed in argon gas, and producing a tremendously detailed signal, detailed X-ray. That means you get better health care.
With the digital radiography, it's almost instantaneous. You've got the patient in the room, you've taken the number of x-rays that you need, you look at the images within a few seconds on our computer screen, and at that point you say, yeah, those are good pictures, you can go.
We can finish each individual picture is done in about 6 seconds, and we can get a complete exam done in 45 seconds, whereas before it takes about 8 minutes using X-ray film. And that means a lot of cost savings, means we can get more patients through, and in places where they just don't have enough capacity at all, it means patients can be seen who otherwise couldn't be seen.
It's really very exciting technology.
A system like this that can bring good X-ray healthcare to people in places that it just doesn't exist means that we're going to save a lot of lives. And saving lives is tremendously gratifying. So that's part of the satisfaction of doing this, is that we're really making a difference.
We chose IDC because we thought they had a great product. It was a different way of doing things, and they had superb imaging. And we felt that they had all of these things at a reasonable cost, which we could afford, and that was the key.
It's one thing to build a sensor that does all these good things, but if you can't afford it, as has been the case up to now, with systems costing hundreds of thousands of dollars, nobody can get the benefit. And we want to see the benefit worldwide. We want to see this in China. We want to see it in India. We want to see it helping stamp out tuberculosis worldwide. Today, we can afford to put these systems into your local veterinary clinic, into the chiropractor, into the clinic in the local mall. Tomorrow, we hope to be able to get it to the point where it's actually cheaper than a film processor. And at that point, it becomes the turnover point, like the DVD player becoming something that everybody's got as opposed to an exotic entertainment system, or the cell phone that practically given away. We're heading there, we're almost there, and that's very exciting for us.